Okay. So the last presentation for today will be presented by myself. I'm Mohamed ElBatanouny from Janney, Elstner. I want to acknowledge also the contribution of my colleague Janney here from Pivot Engineers, and also Dr. Zeel from the University of South Carolina. And basically the topic of this presentation is on development of a database for structural load tests. So as we saw earlier today in Keith's presentation, basically there was a lot of discrepancies between ACI 318.14 and ACI 437.213, which a lot of them has been currently solved by ACI 318.19, basically adopting 437.2. But today I would like to present some more on this topic and the reasoning behind why we want to develop a new database for structural load tests. So ACI 437 committee is the Committee for Strength Evaluation of Existing Structure, has basically formed a new subcommittee with the task of collecting a database for structural load tests. The new subcommittee, which I'm honored to be the chair of, has been formed during the last meeting in Quebec City. So far we have only met twice. But we are basically developing a template to share with researchers and practitioners to collect this data for field and laboratory tests. In this presentation, I will discuss the objectives of the new committee, the purpose of building a test database for structural load tests, and finally, what are the expected outcomes of the effort. So again, this is just repeating of some of the information we heard out today, but load testing of existing structure is part of two codes. ACI 318, Chapter 27, Strength Evaluation of Existing Structures, and there is also a code level document, which is ACI 437.2, which is code requirements for load testing of existing structures. Both documents allow the use of two load testing methods now. The first one is the monotonic, or the 24-hour load test, and the second one is the cyclic load test. And we are fortunate that we have seen some applications for both load testing methods, or discussion for load testing methods today, because I'm not going to go through a lot of details in them. And finally, we also have seen that the use of the maximum deflection as part of the acceptance criteria has been heavily discussed in recent years, which has led to major changes, as Keith indicated earlier. So here is a quick recap on the main differences between the two load tests. The monotonic on the left side, it's essentially a proof test. You just load the structure to a known load. You let it basically sustain that load for a period of 24 hours, and then you unload the structure and you measure the residual deflection, and if you rebound sufficiently enough, then you pass the test. It's very slow to perform. It takes about at least 48 hours to do, but it's very easy to perform, so that's a big advantage. And the criteria is mainly based on deflections. For acceptance criteria, as of now, it's only residual deflections, but for 56 years or so, it was residual deflection and also maximum deflection using an arbitrary equation that didn't change for a very long time. On the other hand, the cyclic load test is a newer load testing methods proposed in the 2000s. It's a performance standard, so you can actually measure the performance of the structure. It's faster to perform. You can do the whole test in less than, let's say, 5 or 6 hours once you have your hydraulics in place. So that makes it a little bit more complicated because you need these hydraulics and you need to react against something to apply the load. And the criteria is based on stiffness. The acceptance is basically through three criteria. The first one is deviation from linearity, which measures the changes in the stiffness of your structure during the load test. The second one is permanency ratio, and the third one is residual deflection. So for the monotonic loading acceptance criteria, again, up to 2014, we had two standards with essentially two different limits. On the left side, you have the ACI 318, which had the residual deflection criteria, and this is similar in both codes. But then you had a maximum deflection criteria of L squared divided by 20,000 H, which was recently removed. But basically, through this test method, you test the structure, you measure the residual deflection, the maximum deflection. If you pass either of the equations, you pass the test. On the other hand, we had ACI 437.2, which also had two equations for acceptance criteria for the monotonic load test. The first one is the residual deflection, same as ACI 318. The second one is a limit deflection of L divided by 180. You can see it's a different limit. And this leads to some discrepancies, as I will show in an example later in this presentation. You can test the same member under the same exact test load, and you calculate the acceptance criteria from each code, and you get a different results because you're not similar, which we are currently working on fixing that by also considering in ACI 437 to actually remove that maximum deflection limit and just use it for retesting. And then for retesting also, we had two different criteria, which again, ACI 437 is currently considering to match ACI 318, so we have some unification here. But the point from the slide is basically maximum deflection limits or criteria is something that's being discussed. There's two different approaches, and since none of them really had a lot of background information about or test data to support, they are currently in the process of being removed from the codes. So for the cyclic load testing, again, you have three criteria. Deviation from linearity measures the changes in stiffness, and if your stiffness decreases by more than 25% during the load test, you basically fail the test. The second one is permanency ratio, which looks at the difference between the residual and maximum deflection in 2 consecutive cycles. And the last one is residual deflection. For retesting, there is still some differences between ACI 318 and ACI 437.2, because ACI 437.2 will allow retesting only if your maximum deflection is less than L divided by 180. As ACI 318 recently referenced the cyclic load test, they have the first point as saying that you can use the cyclic load testing per ACI 437 for stringency evaluation of existing structures. But then right after that, they say you don't have to abide by the maximum deflection limit. You can do a retest even if you exceed the L divided by 180, which 437 say you shouldn't retest if you exceed it. So again, based on all this, their ACI 437 committee felt that there is a need to research a maximum deflection limit for structural load tests, and also there is a need to evaluate how CLT, the cyclic load test method, compares to the monotonic load test method, because both test methods have different acceptance criteria. So moving forward, load test database. So ACI 437A is again a newly developed committee to research the load test database, and basically the committee has decided to take the following approach to collect the data. So first, the members of the committee will identify some papers to collect load test data from. We know, as I work like at WJ, we do a lot of load testing, but we like not usually publish all this information. Some of it is confidential, and we don't want to share which structure we tested. But in other cases, just a load test that we routinely do, and it's not, we're not write a paper from, so it's not published, but we have all this information. Other people like Nestori has similar data, so we are going to reach out to members of the ACI 437 committees that we know they do a lot of load testing to ask them to contribute some of their data that they can share with us. In doing so, we will only ask for general information regarding the structure will be collected. So I guess this is also an extended invitation to anyone that's sitting here and have load test data information that can share. Please contact me or Aaron, and we can share that template we are developing with you. And we are hoping that we have both laboratory and field test data will be collected during our effort. So what is the information we'll be asking for? So the first thing is the structure type. Reinforced concrete or pre-stressed concrete, because we know that there are some differences in behavior between the two structures, and therefore there might be a need for a different limit for pre-stressed concrete compared to reinforced concrete. Currently, they are dealt with similarly in the current version of codes. We will need to know a lot of information about the element itself, so the age, the type, did you test a column or a beam or a slab, What is the span and the depth and the cross-section, the reinforcement, compressive strength, and the expected and calculated capacity. What was the reason for testing? Was it a flexure test, shear, a bunching shear? Any other background information that could be shared will be helpful in that topic. What was the test protocol? Is it a monotonic or a cyclic load test? And is it a field or a laboratory test? The loading and geometry, was it a distributed load or a point load, or are you loading multiple spans? Because all these can make some, can cause some differences in behavior. Test load magnitude, method to calculate, because this has been constantly changing from one code to the other. So we'll need to know what was the test load magnitude. What is the dead load to the live load ratio? What's the applied test load magnitude? Which code were you using, ACI 318 or 562? What year it was published? What's the load? And repairs or a new structure, because again, this could be important for classifying and developing like a maximum deflection limit, for example. Test results, maximum and residual deflections. If you are doing a monotonic load test, we will also ask for like cycles, deflections, and loads if you are doing a cyclic load test. Cracking observed before or during the test. Pass and fail is very important, and it's also important to know if that test actually failed due or stopped due to a different reason other than the criteria. Maybe the cracks were widening significantly during the test, so you stopped it, and then you basically said it failed. We will also like to know that. Retest information, if applicable, because both load testing methods will allow retesting. And what are the response measurements? Deflections, strain, rotation, or other. So again, we, as a committee now, we're working to develop that template, and we will do a trial by us filling it out through some of our data, and then we'll hopefully share it with public so we can get or collect more information about load testing and create that database. So now I would like to show very quickly some example of why the development of the database is important, that what the discrepancies between the two codes could have caused if not being unified like now. So this is a laboratory testing that I conducted back while I was at the University of South Carolina, so about 4 or 5 years ago. We basically tested 20 beams. 8 of them were classified as flexural beams. We expected them to fail in flexural mode. The remaining 12 were shear type prestressed concrete beams, so these were shorter in span, and we deliberately reduced their shear reinforcement so they can fail in shear. And then we tested all these beams under cyclic load testing first for about 14 cycles, and then we applied a monotonic load test, and we did that under 4-point bending with a 4 feet area, that's the constant moment region. Here I'm showing on the right an example of the cyclic loads that we applied, the top right, and the bottom is basically the 24-hour load tests. So going quickly through the summary of the results. So for the flexural beams, looking at the monotonic load test results, if we consider ACI 318-14, which had 2 criteria, one for residual deflection, one for the maximum deflection, which is the L squared divided by 20,000 H. Basically, all the beams passed the residual deflection criteria, which is the first green column. But on the other hand, all the beams failed the maximum deflection criteria, which is shown in the first red column. But since per ACI 318-14, you only needed to pass 1, so all the beams, the performance per ACI 318 was they passed the test. If I follow ACI 437.2 and look at the same beams, residual deflection again passes for everyone because they are the same equation. It is the same equation. But the maximum deflection for 4 of the beams failed. So ACI 437.2 requires that you pass both of the limits, the maximum deflection and residual deflection. And that basically caused 4 of the beams to fail. So you can see a discrepancy here. The same load test method, but different acceptance criteria in different codes lead to a different answer for the same member. On the other hand, for the cyclic load test, which is a little bit more restrictive than the monotonic load test, usually we fail deviation from linearity, which is basically a loss of stiffness, more than 25% of the initial stiffness of the member you're testing, at a lower load than what we tested the monotonic load test at. So in these beams, we usually did the monotonic load test about 80% of the capacity, but the cyclic load test had already failed at like between 50 and 70% of the capacity, as you can see here. So for the shear beams, again, monotonic load test results, we got very similar story. Most of them pass the residual deflection for ACI 318 and ACI 437. For the maximum deflection of ACI 318, they all failed, but since you only need to pass one, again, all the ones that pass the residual deflection pass the load test. On the other hand, ACI 437.2, we almost always failed the maximum deflection criteria, which made the beams basically fail the test. So again, same story. Same beams, same test magnitude, same test method, but different acceptance criteria, you get a different answer. Since ACI 318 now removed that maximum deflection and ACI 437.2 will also remove their maximum deflection criteria, both of these load tests will align. Whether the beams deserve it to pass or not, that's a different story. I'm not going to go into this, but we're now just trying to unify the codes. Okay, cyclic load test. Again, cyclic load test failed at a lower load level than the load level we apply the monotonic load test in. And here I'm showing just a summary. So for the shear beams only, you can see all the ones that pass the 318 test are highlighted here in green in the third column. While for 37.2, again, some of them fail the deviation from linearity at a lower load, but they still pass the monotonic load test. So basically, the summary is the cyclic load test is more restrictive. Which one of them should the practitioner follow? Currently, the codes allow you to use and to choose whichever one is more suitable for your need. But you can see from here that CLT is more conservative. So in summary, laboratory testing that was conducted on pre-stressed beams shows that ACI 318 previous maximum deflection limit always failed for the tested pre-stressed beams. The difference between the maximum deflection limit of ACI 318 and 437 give inconsistent pass-fail results for the same members. This has been corrected now, or it's in the process of being corrected. The CLT and monotonic load test give inconsistent results when used to evaluate the same members. Finally, the newly formed subcommittee, ACI 437A, will collect and evaluate load test data with the aim of developing, hopefully, of course, a new maximum deflection limit and also evaluating the acceptance criteria of both methods. Because ideally, you can test the member using CLT or monotonic and get the same result. You shouldn't be getting a different result. And I think that this was the last slide, so thank you.